Hi, today's lesson is lesson 16 on something called the mole. For this lesson, you need a calculator and your data booklet. So this lesson is on the mole, which is basically it's talking about a group of things in chemistry. Now, the reason why we talk about a group of things is because the things we talk about in chemistry are really tiny. So we talk about atoms and molecules that are in something, and they're just so tiny that we group them into a bigger group and talk about one mole. It's kind of similar to how we might talk about a dozen eggs. Instead of talking about one egg, we might group them into a group of 12 and talk about a dozen eggs. Same thing here with atoms. We're not going to talk about one atom. We're going to talk about a group of atoms called a mole. Now, how many atoms make up a mole? Well, it's this number down here, 6.0 times 10 to the 23. You haven't looked at scientific notation yet because we haven't done physics, but what this number here means is it means that number. That's a huge number. And you can watch videos explaining exactly how big this number is. That will help you understand it. But this is essentially how many atoms or particles or molecules make up one mole. Think of it as how many eggs make up one dozen. This number is called Avogadro's number, based on a scientist who discovered this number. And it just makes the math a little bit easier because as we can see, we end up working with ginormous numbers of atoms and molecules, and it's just a little bit easier to group them together. Now we're going to find something called molar mass. Molar meaning mole, and mass meaning the mass of one mole. So how much is the mass of one mole of something going to weigh? Now, it'd be really hard for us to figure out and use such a small number as the mass of an iron atom. But we can put a whole bunch of iron atoms together, 6.0 times 10 to the 23 to be exact, and we can measure a mole of iron atoms and we can get a more reasonable number. It's even going to be measured in grams. So it's actually going to be a lot easier to do the math if we talk about the mass of a mole instead of the mass of one molecule. Now, underneath the name on the periodic table, you're going to find the molar mass of elements. So let's go to our data booklet. Let's all go to this page on the periodic table, and we'll take a look at some molar masses. So right underneath the name, let's start at hydrogen, is a number usually with 2 decimal places. So 1.01 for hydrogen. Lithium is 6.94. Beryllium 9.01. What these are, if you scroll down a little bit and you look at the key at the bottom, is these are going to be the atomic mass. That means that is the mass in grams of one atom of whatever you're working with, okay? Or one mole of whatever you're working with. So let's take a look at some examples here. Determine the molar mass for methane gas. So we're taking some, or one carbon, I should say, secret one, and 4 hydrogens, and we want to figure out what the mass of one mole of that would be. So let's write this in words first. 1 carbon plus 4 hydrogen. And what I'm calculating is molar mass, which you can call capital M. We don't want to call it lowercase m because that means mass of a substance, and we're talking molar mass, the mass of a mole. Now I'm going to do a little bit of math. I'm going to go 1, and I'm going to multiply by the molar mass of carbon, and 4 times the molar mass of hydrogen. So I'll show you where we find these numbers on the data booklet. The atomic mass for hydrogen is right here, 1.01. And for carbon, it's 12.01. So we can sub those into our equation. And into our calculator, we can put exactly what we see with the brackets and everything. And we should get 16.05. Now, if you're wondering what the units are, I can show you that your data booklet has a lot of information for you. Your data booklet will show you exactly what the units are for all the calculations that we're doing today. Go to page 10. Near the bottom, there's this section called stoichiometry and solution formulas. What we're starting to practice is something called stoichiometry that you practice more in grade 11. And we're specifically interested in the first formula, N equals M over M. And we have over here what all of those things mean. Specifically for this question, molar mass. And it has the units right at the end, grams per mole. So grams per mole. That's telling you that if you have 1 mole of methane gas, it is going to be 16.05 grams. If you have 6.0 times 10 to the 23 particles of methane gas, that's what a mole is, it's going to weigh 16.05 grams. Let's try a more complex question. What is the molar mass? I look in my data booklet and see that that's big M of NH4 with a 3 behind the bracket, PO4. So if I think about naming ionic compounds, that's going to be ammonium phosphate. Now, we need to do some multiplication to figure out how many of each element there are. This 3 is applying to the nitrogen and the hydrogen. There's a secret 1 behind the nitrogen, so I'm going to go 1 times 3 and write 3 nitrogen plus 4 times 3 for hydrogen, which is 12. Now, the 3 only applies to the NH4. We're done with the 3. I see a secret 1 behind the P. There's no brackets telling me that that 4 should apply to the P as well. So that's 1 phosphorus and 4 oxygen. Once we have it written out in words, we're going to write 3, and then in brackets, I want you to find on your periodic table the molar mass for nitrogen. Again, it's going to be right under the word for nitrogen. So here I see nitrogen has an atomic mass of 14.01, so I put that in the bracket. 12 hydrogens. You might get to the point where you do so many calculations, you start to have some of them memorized like I do. 1 phosphorus and 4 oxygen. Now put this in your calculator exactly how you see it. The brackets are important. You need to make sure that you follow BEDMAS and you multiply before you add. So this one takes a little bit to enter it in your calculator, but stick with it. Check your screen to make sure you didn't make any little errors on your calculator. And you'll get the molar mass of ammonium phosphate to be 149.12 grams per mole. If I get 1 mole of ammonium phosphate, that's exactly how much it's going to weigh. That's what it's telling you. Now, molar mass of carbon dioxide. Carbon dioxide is CO2. So I need to have 1 carbon and 2 oxygen. Both are elements that you've already looked up on the periodic table. So carbon is 12.01 and oxygen is 16.00 grams per mole. Add them up and you get 44.01 grams per mole for carbon dioxide. Very important that you put the proper units. There's no excuse not to put the proper units because they're right in your data booklet. We don't even expect memorization. We expect you to be able to use the tool that we're providing, which is the data booklet. Here is a snippet of exactly what the data booklet says. The formula for number of moles is N equals M over M. It's important that you guys can tell the difference between your lowercase m's and your uppercase. So mine both look really similar. So I usually try to do my lowercase really, I don't even know how to describe it, like soft, rounded M. And I try to do my uppercase like a big pointy M, just so it's obviously different. Some people will do like, I don't know, add a little handwriting flair to their M, and then like I am doing a big pointy M kind of thing, just so you can tell the difference between mass and molar mass. So here's how we write the units. Number of moles is MOL. You do not abbreviate that. That's already abbreviated. It stands for MOLE, mole. And we use that because just an M by itself means something in science. What does M mean? It means meters. So we can't be confusing ourselves and saying M for two different things. So we say MOL. We do not abbreviate any shorter than that. The mass, if I went to the chem lab right now and I measured out a certain mass of substance, I would measure it in grams. And then the molar mass that we just learned how to calculate is how many grams per 1 mole is something. So in this question, they're asking how many moles, so number of moles of silicon are in a 56.18 gram, so this is a mass sample. The units in the question tell you exactly what you're given. Now, the first step usually is to take what you're given and calculate the molar mass like we just did. So I need the molar mass of silicon. So I'm going to look and see if silicon is on my polyatomic elements. It's not. I don't see it in that little tiny box. So it's just going to be Si if I write the chemical formula. And its molar mass is 28.09 grams per mole from the periodic table. The mass is 56.18 grams. And I want to know number of moles. So I'm just listing all of the things I've been given and what I want in my list here. You'll see that I do that in physics in our next unit too. Once I list them, I write down the formula from the data booklet. Let's make that pointy so it looks different. Okay. And I sub in my numbers, being very careful to follow the formula. Mass goes on top and molar mass goes on the bottom. Now that's a simple division. Put that in your calculator. Divide those two numbers. And I'm getting the number 2. but I'm actually going to write my number with what we call 4 sig digs. This is just so that your notes are proper. I'm not going to teach you sig digs until we learn physics, but they do apply in chemistry as well. It's just better learned when we start talking about physics. Now, what happens with these units is really important if you plan on taking Chemistry 20. So if you don't plan on taking Chemistry 20, you're just thinking about N, you're looking up here, and you're saying, okay, that's measured in moles, so my units are moles. Done. If you're planning on taking Chemistry 20, I want you to think through this unit that we get here. When I take grams and I divide by grams per mole, I can write it horizontally instead of vertically like that. Now this grams is actually with a secret denominator of 1. Anything that doesn't have a denominator, we can write a secret 1. Now, how did you divide fractions back in junior high? You left the first fraction alone, you changed it to multiplication, and you flipped the second fraction. Now, what do you know about fractions when they have the same thing on top and bottom, like the grams here? Same thing on top and bottom of a fraction that's multiplying can cancel. So what do we have here? We have moles over a 1, which we don't even have to write. In chemistry, you should be able to analyze the units and know if you've calculated everything correctly, because the units should end up being exactly what you want them to be. We were looking for number of moles, so we should have gotten moles. Let's try another question. What is the mass of 10 moles of water? Now we're looking for mass. That's our question mark. We have 10 moles, that's number of moles. And we always have molar mass. We just need to calculate it. That's usually the first step. So water is H2O. Molar mass would be 2 hydrogens plus 1 oxygen. Hydrogen, I actually have that number memorized, as do I for oxygen, because we use these ones a lot. And here I go, entering it in my calculator. And I get 18.02 grams per mole. So I can list that in everything that I have. The question is never going to give me that number. It's going to assume that I can use my periodic table and find it myself. So I need to know how to calculate molar mass first. Now I can write my formula from my data booklet. And I can sub my numbers in and solve for mass. So number of moles on this side is 10.0. I don't know mass, but I know molar mass. Now in chemistry and physics, we don't get lazy. You're not going to write 10 and 18.02. You're going to always write the units with them. Okay, that's a must. You're also going to write all of the decimals. Even though 10 and 10.0 are the same, they're not necessarily the same in science. Again, I'm going to teach you that later in the physics unit with something called sig digs. Now, how would we solve this if we want to get m by itself, but it's dividing by something? The opposite of dividing is multiplying. So you're going to multiply both sides by 1802. On the right-hand side, top and bottom cancels, and you're left with m. On this side, 10 times 18.02 is going to be 180.2, and mass is always measured in grams. Those students planning on taking Chemistry 20, I want you to analyze what happens when you take 10 moles and multiply by 18.02 grams per mole. Can you see why we end up with grams? If you're getting the hang of this, pause the video and try the next one on your own. How many moles are in 360 grams, that's a mass, of glucose? I'm going to go to page 10, or pardon me, page 5 of my data booklet. And I'm going to look for glucose in this big list of elements. Glucose is listed, I found it, C6H12O6 solid. We need to find the molar mass of glucose. 6 carbon, 12 hydrogen, and 6 oxygen. That's going to be 6 times 12.01, 12 times 1.01, and 6 times 16.00. I'm going to my calculator now. I'm being really careful to punch it in exactly how I see it. And I'm getting a molar mass of 180.18 grams per mole. So I can list that over here in my list of things that the question has given me. It didn't give you that straight out. It didn't say, hey, the molar mass for glucose is this. But it always secretly gives you the molar mass when it tells you what you're working with. You just have to use your periodic table, do your multiplying and adding, and you'll have the molar mass. Now, number of moles is mass over molar mass. Sub in your units as well. And people planning on taking Chem 20 need to analyze the units as they go. This is a division question. And see how the 360 has 3 numbers in it? I'm going to write my answer with 3 numbers in it. It was 1.998. So I rounded it up to 2, and I put some zeros just so I could see 3 numbers. We'll figure that out later. Don't worry too much about that now. Now, Chem 20 people, grams on top and bottom cancel. Now you are dividing by. Remember that flips the moles up. And you end up exactly with the units that you would have expected for number of moles. Here's another one to try. You can pause the video and see how far you can get on your own. We're looking in this one for mass of 5 moles. That's a number of moles of NH3 ammonium, I believe, or ammonia, pardon me. So NH3 is 1 nitrogen plus 3 hydrogens. If I look on my periodic table and find nitrogen, the atomic mass is 14.01. Hydrogen, I already have memorized because we used it a lot today. So into my calculator I go, and I'm getting 17.04 grams per mole that I can now list over here in things that were automatically given to me, even if it was kind of in secret in the question. Now you always write the formula down from the data booklet first. And I'm going to show you how to rearrange this without numbers. Those of you going to Chem and Physics 20 might want to be able to rearrange a simple equation like this one without subbing numbers in first. I'm looking for mass. I want mass by itself. So I need to get rid of division by m. What's the opposite of dividing by m? Multiplying by m. That's the same step that we would have done if that m was a 2. I would have said, what's the opposite of dividing by 2? And you would have times by 2. You can do the same thing as long as you do it on both sides with a variable as you can with a number. The same thing happens with variables on top and bottom. They cancel, and you end up with mass equals number of moles times molar mass. I'm going to use this equation. You can use the original equation if you like. You should end up with the same answer as me. So number of moles was 5. Always put your units into your work. And we're multiplying by molar mass, the number that we just found in the first step. Now I'm getting 85.2, and since this is mass, it should be grams. Future Chem 20s, look at the units and see if you can decide why we're left with grams and the moles cancel. What's another way that you could write grams per mole? You could write it as a vertical fraction. Then you have over here moles in the top and moles in the bottom, canceling to give you grams. That's how the units end up working out for this question. Now there's a few worksheets in the practice booklet, and that'll bring you to the very end of chemistry, and we're actually all done except for a video where I'm going to show you all of the labs that we would have done to help you understand the different types of chemical reactions, and then we'll be moving on to physics next week. Please let me know if you need any help with this stuff.